Hello and welcome to this special episode of Factorio Single Belt, where I will show how the circuit network works. The thing is, I got a lot of views on my channel a couple of days ago, and there were some comments saying that they didn't understand the circuit network, that it was really big and confusing basically. And I kind of agree. So, I kind of agree when it comes to the full circuit network. So what I'm gonna do in this episode is to show the basis of it, how it works and what works. And then from that you can build this whole crazy circuit network that I have. But first things first, I have created a loop. This is only a single belt loop, but it would be the same with a double belt loop. And I have some raw material, which in this case is iron plates. And I have set up an assembly machine to create pipes. I haven't connected this yet. I have also set up, let's see. This setup is for storing iron plates. Let's see what happens when we put iron plates onto the belt. Oh, by the way, this one and this one, that's only to create a delay. And it will become probably part of the loop, part of the belt eventually. But for now it's enough to just see what's happening. So without anything picking stuff up, this is what's happening. We are feeding iron onto the belt, it's going around, it's coming back over here, and if I just set this to collect the iron plates, this is collecting iron plates and putting them into this chest. Now let's stop this. Just turning that around to stop it. So everything that comes before will be collected and put in this wooden chest. Well, maybe I should put a steel chest here instead and put a bit more iron plates in there. Let's keep a few stacks just in case we need to construct something. I have set up all of these lights. Hopefully that will be enough to light this up so that we can, that it's possible to see everything even during the night time. Over here, I have basically done the same thing but with pipes instead. So we have the pipe collection, goes into this chest, goes into this, and then we feed it out. Coming to think about that, maybe we should have a chest over there as well. There we go. So now for the basis of the belt setup. Well, let's see. Let's just place a power pole. I have everything powered. I'm using the power poles basically for the wires. So I don't know how much you know, so let's go through the basics of the circuits. Basically, you can read the contents of a chest. I'm connecting it to the power pole. Hovering over it will show the contents in that chest. And let's say we put 21. Oh, oops. No worries. We will get those. Pipes back. So there is 19 pipes. If I hover over the power pole, we can see that there are 19 pipes in the green circuit network. There are two networks, one green and one red. But let's just use one of them and not worry. If I put other things in this chest, it will show all of those items. Let's also say we rotate that. Oh, there we go. Oh, that's actually good. We have 19 items over there. Let's put some steel. If we connect several chests, it will add everything. So we can see that there are all the steel from here and all the stuff from here, and there are 21 pipes, which is the 2 here plus the 19 over here. Now let's pick everything up. So that's how you measure things from chests. Then we have this constant combinator. We can basically select what that should show. And we select that it should show 10 pipes. We connect it with a wire, and then we can see we have 10 pipes. We can also say that we want a negative amount. So we want minus 10 pipes. And then it will show that we have minus 10 pipes. Great. So what have this got to do with the network? Well, first of all, I'm not connecting up this, so let's remove that. And we have minus 10 pipes. Oh, minus 10 pipes in the network, since this says we have minus 10 pipes. What happens when we add pipes into this chest? Well, you add the results, minus 10 plus 21, or 21 that we have over here, minus 10, that's 11. So it will show the number of pipes we have in the system. So that's that's how we set how many pipes we have in the system. But we also want to make sure that the iron, aren't just being fed out onto the belt like this now. We want to stop that. We want to make sure that, oh, that wasn't big enough. We want to make sure that this doesn't feed out unless something is requesting it. So let's connect this inserter to the network. This is not the same network. This green line and these green lines aren't connected. But as soon as an inserter is connected to the network, it stops. And then you can change a few things here. Right now, let's not do that. We are getting everything back. Let's connect the networks to each other. There we go. And now we can see we have 11 pipes. So what we want to do now is to make sure, we want to make sure we always have, let's go that way. We want to make sure we always have 10 pipes in this chest. That's why we set it to minus 10 here. The idea is that this minus 10, let's remove the pipes, this minus 10 will show over here, and it will trigger this inserter. So by setting the pipes, when we have less than 0 pipes, we have minus 10, then it will feed out iron. That's basically what we are doing. And then we want this factory to actually start working, and it requires 1 iron plate. So let's just add some inserters. Input and output. And that makes sure that we get some pipes being created. And we are filling this up. So whenever that hits 9, 10, this will stop outputting stuff. But we have gotten quite a few more pipes being created. Let's pick up the pipes again. Oh no, I shouldn't have done that. Let's put them back into the chest. Oops. Yeah, the thing is that as long as this machine doesn't have any pipes, we will still pick up iron and we will output pipes, no matter what we have set this this chest to. And if we only have this iron and this pipe production, that's kind of okay, because this is feeding out, this is using all of the pipes or all of the iron, transforming it into pipes and storing it, and once we have 10, this stops working. And yes, it will take a little bit of time, but eventually we have like 15 pipes, 5 pipes more than we need. That doesn't matter that much. But let's see what happens if we have more space, or a bigger area before we get into this pipe assembly machine. So, of course, normally during this belt there would be other assembly machines and all of that, but right now we are only interested in making it longer to see what happens. So let's pick up our pipes again, and this starts outputting really great, and eventually it will go down to the pipe assembly machine and we will start getting pipes. This will take a little bit of time. Oh, maybe I should have created a few more lamps. I didn't realize that we didn't have any lights over here. Let's fix that. Like that. And we can see pipes are being created. We get, if we read the system, we have -3, -2, -1, and we have all the pipes we need. And this stops feeding out iron plates, which is great. But at the same time, we still have a few plates on the belt, and those are being fed into this chest, making it quite a few extra pipes we get. So when we are finished with this, let's just make sure we get finished with it. I think we are finished now. We have 42 pipes instead of the 10 we want, and that's way too many. And if we had other assembly machines, it would basically work the same way. The machine over here, if that requires iron plates, would get everything, and then we wouldn't have space enough. And also, one other thing, let's say that I don't know how many pipes we can stack. We can stack a bit more. Let's remove that, and let's pick up the pipes. Again, actually, I don't want to do that. I want to leave the pipes. I think it's 100 pipes in a stack. Mode of operation, none. Then it will not do anything with the circuit network. It will just work. So one other thing that can happen, I took this and limited it to make sure that we can't have more than one stack. Actually, I know, that's wrong. I should have set it to enable disable and then set this to, let's say I want 150 pipes. 150 pipes. We now miss 61 pipes, which is quite okay. So what happens is that this should stop at 100, if I'm right. I hope I am. Yeah, we can't feed any more into the system, and we start getting pipes on the belt. And if that's not enough, this will keep on supplying, because we can't get more than we can't get to 0 or positive amount of pipes. So everything will still continue working, and let's set it back to what we really want, which is 10. So we have 90 pipes more than we need, but this assembly machine is still picking up all of the iron and converting it into pipes. So let's connect this. We are connecting the output and say that if pipes are less than 0, we should output things, otherwise we shouldn't. Which means that it have picked up, it have created 4 pipes, but there's no way of getting rid of it, so this assembly machine stops. And if we set it back to 150, it will start outputting and we will start getting... Oh, wait, why didn't I change this back? There's no reason for this extra loop anymore, I think. Yeah, so this will start producing and feed it out. But we want it back to 10, which is the original amount. There we go. But we still have these 4 pipes in the assembly machine. And I don't like that idea. We have 4 pipes that we can't use for anything, which honestly, in this case, it's only 1 iron plate each. So it's not too bad, but it have used 4 iron plates. And if we are looking at something more complex, we have used, for this stack filter inserter, we have used 60 iron plates, 39.5 copper plates, 2 plastic, which have been converted, and that stores extra and so on. If we go to the really complex stuff, you can see it escalates. And these 30 blue circuits, they are crazy expensive as well. So that escalates. I don't want a lot of stuff in the factories. So let's remove this instead. Let's feed it out. And let's instead stop the input. That means that, yes, sure, we have, let's pick up all of the pipes. Yeah, and now we get more, wait, oh, I forgot, I have to set this to if pipes are less than 0. That means that we don't keep anything in the assembly machine. We are stopping the input, which is a bit less expensive. We don't have any output. This is possible when we have one item, creating one item, or several of the same item. Of course, if we have several different items, we might have some things stuck in the assembly machine, but never mind, it's better than the alternative. Okay, let's see this in use. So we are feeding out iron plates, we are constructing the pipes, and it's being stored over here. Oh yeah, that's set to 10. When we have negative, some amount that's positive, more than 10 or 10, then this stops and this stops, which leads us to 12 pipes instead of the 15. And we are not feeding any more iron onto the belt. So this is basically the start of it. There is one other thing we have, and it is this lamp. Basically it is set up to say the same. This inserter should have some setup, enable configuration, which should be the same as the lamp, meaning that when the inserter works, the lamp says that this is working, this is feeding out stuff, and when it stops, the lamp goes out. We have plenty of iron. I was afraid we didn't have enough. Okay, there we go. And everything is good. Now, if we have more assembly machines than that, we just have the same thing over again. Let's see. We connect that. Copy paste, copy paste. And we can see this in work. Actually, let's go for fast inserter over here to make sure that both assembly machines can work. And we can see both assembly machines are creating pipes. And when we have 10, the input stops in both of them. Okay. So this is all good. But what happens when we add another type of item? Oh, by the way, to feed in from the normal factory contains 2 belts or a double belt. So to feed in from that, we just connect long-handed inserters and connect those. Oh, come on. Connect those as well and set those up the same to say that the pipes. And then they won't be used until this is empty. Great, everything is working. Now, what do we do if we have another type of assembly machine? Well, by the way, let's remove these long-handed inserters. They are not really important. Let's say we have another setup on this side, which is iron gear wheels. The iron gear wheels only takes iron plates. They take 2 iron plates to get one iron gear wheel. And then we set up the same setup on the left side of the belt. There we go. And we connect this. Oh, I forgot about this. We set this up to say that we want iron gear wheels and we want -10 of those. The same we have over here. We could have all the constant combinators. Well, I could add the iron gear wheels over here as well if I wanted to. And only have 1 or 2 constant combinators. Basically, I could place all of them in one area. That wouldn't create any technical problems, but it might cause some other problems. Let's connect this to the wire network and we are using the substations. Now we can see that we have -20 iron gear wheels. That's because I added it over here as well. Let's remove that and we should have -10 iron gear wheels. Okay, we want to do the same as we have over here, which is to connect this one, this chest. We want to disable this inserter, and what do we want? Oh, we want to set this to iron gear wheels. Okay. So, we more or less have a working system now, except that we really don't, because this inserter, everything is connected to it, we can see what we have, but this inserter have a condition to say pipes. How does that work? We need it to be we need it to be iron gear wheels, and then it will work. And it will create iron gear wheels. Actually, I should, just to make this as fast as possible, I should use fast inserters. That makes it a little bit easier. And we can see we have 0 iron gear wheels, we have a positive amount, and this now have stopped outputting. Great! But what happens if we have a negative amount of pipes? Well, that doesn't work. We don't have we have set this to ion gear wheels instead. So now when we don't have enough pipes, it won't work. Okay. What can we do about it? We can set it so that when anything is less than 0, then it will feed out. Oh, I forgot about this inserter. This should of course be set up to when ion gear wheels is less than 0. Okay, so now we have nothing that is that's using that have a negative amount, and we have set this up to anything. So if anything is a negative amount, then the ion will be fed out. That sounds kind of good, I guess. But what about our next setup? And this setup, I won't complete it. I will only show what would happen. This setup is copper cables. The copper cables takes a copper plate. Okay, let's do the full setup. Damn, my mouse is really bad. Oh, I should do that, and I should do this, saying that this is copper plates, and then I should connect it with a power pole and connect it to the circuit network. Let's see, what do we want to connect? We want to connect that, and we want to connect this one. Oh, and then we want one of these as well. Let's set this up to copper cable, less than 0. Great, this works. Let's set this one up to the circuit network. We haven't put any value in this, so one thing with this game is that it doesn't convey 0. It conveys positive or negative amounts, but not 0. But let's see what happens when we set this to a copper cable -10. Well, we have -10 copper cable, and copper cable are made from copper plates, but we get a lot of iron onto the belt. That is not exactly what we wanted. We want copper on the belt, not iron. So the idea of setting this to anything doesn't really work. What else do we have? Well, we basically don't have anything to say items that require iron to be constructed, which is what we need. So we need to build that ourselves. Here we have all logistic things, production, intermediate products, combat products, and fluids that we can set up. This signal part, that's a little bit special, because these are stuff we can modify ourselves. So let's say, just for the moment, we want to stop this. I don't want it to run, let's just set it to A. Great, then the belt will be cleaned up. We still have this requesting stuff, or we still have this copper cable, but this have stopped. Okay, so how do we set up this to only feed out when we want ion gear wheels or pipes? Well, there is basically 2 ways. Either we say by the pipes that when this is wanted, we want some kind of signal to say that we want iron. And we set up the same at the ion gear wheels. That is a bit more complex than what I have done, and it works great, don't get me wrong, it really does. But it's not the way I want. The thing is that I don't think we have enough kind of cables. We only have green and red wire, and I would need like 1 or 2 more colors to make that work. At least I think so. So what we do instead is to use the combinators. Combinators and the decider combinator in special, in particular, yeah, whatever you say. You basically say that when you get something in, then you get something out. So this is a bit... I don't like how the decider combinators work, but never mind about that. What we want to do is to say that we want to output A. Let's say that this will react on A. We want to output 1A instead of outputting some custom thing, or outputting the iron gear wheels or pipes or anything. So we output 1A. When do we do that? Well, we do that when pipes are less than 0. Okay, and we have 2 connection points to these combinators, 1 input and 1 output. So let's connect if we can. Let's connect the input onto the system we have, and let's connect the output to this power pole. This is of course a bad placement, but it's only to show. And I'm using the red wires, not because I need to. I could use the green wire, and you can see when I hover over that power pole, this green wire lights up, meaning that that's the whole wire system. If I hover over this, the rest of the green wires lights up. But I find that using red wires makes it a bit more, a bit easier to see that this is actually another circuit network. And you can use red wire on the same power poles without anything being without the signals being merged. So let's remove everything from the pipes and the iron gear wheels. Since we set this to A, nothing will be fed out. So now we can see in this we get in -10 pipes, -10 copper cable, and -10 iron gear wheels. And we output 1A. Since we have the pipe less than 0, we output 1A. So let's disconnect this inserter from the network. Actually, let's turn it around first. Otherwise it might start just pumping out things. So we are outputting 1A, and you see the box around this one is red. If I hover over this power pole that is connected to both the networks, you can see that there is 1 red signal, that's A, and there is 3 green signals. But let's not worry too much about that. This is 1A. Let's connect this one to the inserter and see when let's turn it right. When A is less than 0, then it will enable. Well, we are outputting 1. There is no button for -1, and we don't want to do some calculations that would work, but there's no reason to. So let's change this to when it's more than 0. We want to output. And we can see we are getting pipes being created. Everything is being worked on. And we stop outputting because we have enough pipes. We can still remove all of the ion gear wheels. We haven't done those. So everything seems to be working. What do we do to get the ion gear wheels as well? Well, it's easy. We make another one of these cider combinators. And we connect it. And connect it. And we can copy paste what we have. We copy paste from this one into this one, just to make sure that we don't have to set up everything. And then we change this from a pipe to the ion gear wheels. So now this is 1A because we have ion gear wheels. We are missing ion gear wheels, and the ion gear wheel situation have been fixed and everything is good. Let's see what happens with if we don't have enough pipes. There we go, we don't have enough pipes, so we are getting ion plates onto the belt, and we are constructing pipes, and all of that is done. Great, but what happens if we don't have any of them? Well, it still outputs, and A is 2, but since we set this to A is more than 0, it doesn't have to be exactly 1. It can be higher than that. So let's connect this back up, this lamp. We want that to be A is more than 0, which is the same as the inserter, and everything is working. And this is basically the way we are doing stuff. Now, this is everything, and it will fill up. However much it will. Okay, there we go. What happens if we have a more complicated recipe? This only requires ion plates, and this, okay, it requires 2 ion plates, but still only ion plates. So let's see this in use with a more complex recipe. So let's build one more setup over here. And just for the sake of it, let's use fast inserters. Let's see, what more do we have? We have that, and we have, oh, let's just turn that around. Oh, by the way, yeah, let's look at these ones. Maybe we should add a lamp over there as well. Let's look at these inserters. Let's actually turn this around, because we don't want any new stuff onto the belt right now. If we, well, why not? Let's turn it the right way again. If we turn these back into the real position, then they start feeding stuff onto the belt, and we start getting more stuff onto the more ion plates onto the belt and construct things. So these need to be stopped, but we have nowhere to connect them yet. But we can connect them just to the lamp. Then they will stop. Yes, we have nothing connected to these yet, so they will never work. But that's fine. That's totally fine. Oh, maybe I should let go of the limit of this. So that way we can stop everything, have everything set up, but nothing output onto the belt. Okay, now back to this. Oh, let's do that over here as well. Back to this. We want underground belts. Pipe to ground. The pipe to ground, they take ion plates and they take pipes. So how do we do this? Well, first of all, we want to set everything up and connect everything to the circuit network. This one. Oh, And there we go. Now we should have everything over here, yes. And we have piped ground. There we go. We want 10 of those as well. There we go, we have -10 piped grounds. This is filtered to piped grounds somewhere. We copy paste this and set it to piped ground when that is less than 0. Great, so this is basically ready to be started, I think. The only thing is that we lack the ingredients to do it. So let's set another one of these up. We needed iron plates and we have set that up, so let's just set this up. Piped grounds, and this starts feeding out. What happens now? Well, we will see in a second, but basically it feeds into this assembly machine until we have, I think it's 3 times what it takes to create one of these, which is 15. And then it can't feed anything else. It needs the pipes as well. But this one still knows that we don't have enough piped grounds, so this keeps on outputting iron plates. What we need is to make sure to get pipes as well. So let's do a similar setup to this one, but on here. And right now I'm gonna be a bit lazy because I know that we will only need this one thing. So let's connect it like this. And the input is when piped ground is less than 0, then we output A1. And since we have this set up only here, this red wire doesn't have anything to do with this red wire. So the A signal that we are using doesn't cause any problems between this one and this one. Let's copy paste this. Let's copy paste this. Then we can see that we are outputting, we are feeding out pipes as well. And we are getting them into this assembly machine. Things are being created. Maybe I should put a faster inserter over here. And when we get too low on the pipes, then of course this still keeps on feeding out, but we are using a bit of the iron to create new pipes to make sure that everything balances out itself, more or less at least. I should have kept the slower inserter, because these two assembly machines can make sure that we are building up enough. Oh, this is already done. Let's make sure to empty the system and then do it again. I think that's a good idea. And let's do it with all of these extra bits of belt, just to see what happens. Remember, nothing happens here. Normally it would be other assembly machines or something. This is just to make sure we get a further area to travel. And yeah, we have those 4. Let's not worry about that. And we remove all of those. By the way, you can see that we have partially what it takes to create one new pipe, even when we were finished. That's not a big deal. But yeah, we are starting to output a lot of iron, a lot of pipes. And we can see we are missing pipes, which means that we will get all of this iron to be for the production of pipes. Well, a lot of it at least. And then we have the pipes over here. And we can see 5, 6, 7, 9, 10. Oh, we get a few pieces of iron post the pipe production. I didn't think we would get that, but that's fine. Now what happens is that we have enough pipes, but we don't have enough iron, so we can't produce any more. We need to wait until the iron gets passed. And the iron gets passed pretty soon. So this is basically how it works. I'm just putting another assembly machine, hooking it up to the ones behind, and then we get more and more. And when it's about the inserters, I can choose between having these inserter, fast inserter, or let's see, where is it? The stack inserter. I mean, I could go with this one instead, getting 3 of them every time and set the stack size if I wanted to, override that. This, of course, puts out way too much on the belt, so I'm not doing that. And yeah, even the fast insert, I haven't researched larger stack sizes, because if I did, it would create kind of a problem. It would fill up the belts too much. And anyway, in a single belt factory, the inserters aren't the problem, the belts are. The belts definitely are the problem. So you can see that we get everything created, and well, I should really ignore these extra lines now. They don't do anything. They just showed how it would look. But you can see that we have we have exactly 10 underground pipes. We have some of the products to create more, but not all of them. But we get way more pipes than we had before. Is that good? No. Could I have done something to circumvent it? Yes, but that would have been really complex. We get 35 pipes. That's why the amount of raw material in the chests differ so much. It's because when we are using something, we are creating an enormous amount of it, and then the next time we need it, we are not creating anything. Let's see what happens if we remove one underground pipe. I don't think that the amount of pipes will go below 10. There we go. Now we have 1 extra underground pipe, and we still haven't created any new pipes. We didn't need to. So although it's not ideal, it does kind of balance itself. It would be nice, especially for the more expensive stuff, to say that we need that, and then we have something that remembers how much is needed and all of that. But I haven't set it up that way, and I probably won't do it. Not in this factory, at least. But anyway, that is how the circuit network works in this in the factory I have, the single belt factory. If you have any questions about this, or any questions about what more things we have, because I haven't shown everything, I know that. There are a few more items. If you have any questions about that, please make a comment, and I can either answer the comment or I can make a follow-up video where I answer comments. Anyway, thank you a lot for watching, and hopefully see you in the normal series. Bye!